Today we are going to have a demo on the CBC OH, which is now fitted in the Loco 24408, stopped for the TOH activities. So CBC, as everybody knows, it's an important component in the locomotive, and it's a center buffer coupler. It is generally coupling the two equipments and transferring the buffing load as well as drafting load, both are absorbed through this. This is knuckle, very important component. This is coupler body, it's a part of the CBC coupling. The next one is knuckle, clevis, screw coupling, lock, knuckle lock. That is a transition rod which is used for opening and closing the CBC assemblies. This is yoke. This is a drop gear. This is a yoke support plate. Yoke pin support plate. In connection with our CBC OH, some gauges are generally used for measuring the correct dimension so that we can give a fitness for the CBC. In this context, the first one is 10A counter gauge. The second one is knuckle stretch limit gauge, knuckle nose wear gauge, and snap gauges are there for the screw coupling. Snap gauges. Then gauge 1 and gauge 2, it measures the distance between the coupler body and knuckle. This will be used, that it will come in the next part. Then this is internal caliber. This is scale, measuring scale, normal scale. Profile pitch gauge. This for the screw coupling profile is checked during the course of the CBC OH. Before removing the CBC, we have to ascertain the working condition of the CBC. For that, we have to move the coupler body to left and right. Just we are moving it. It should freely move left and right. That shows that this is okay. Now this CBC's condition is okay. Now another parameter, we have to measure the distance between the striker casting and coupler head. That the measuring, that the limit is 108 plus or minus 25. Now we are measuring it. The measured value is 110 mm. So this is within the limit. So it's okay. Another, we are going to have a gauge 2. Gauge 2, generally it is used for checking the distance between the nose of the knuckle and the guard arm. The distance is supposed to be 130 mm. It should not pass. It should not pass. It should not pass. Now this is not passing. If this gauge 2 passes, then the knuckle and the knuckle pin, it is in the damaged condition, should be changed during the OH activities. So the next one is, you are going for the gauge 1. The diamond, the length is 135. The same place what we used in the gauge 2, the same manner we have to use the gauge 1. This also should not pass. Now this gauge also not passing, so this is in good condition. Now both the gauges are not passing. As far as that CBC is, it's okay. Now we can take up for the OH. But if it is passing, the coupler body, knuckle pin, all are to be rejected. So we have to go for the another coupler. And one more, the contour of the knuckle to be checked, we are going to check up. Contour of the knuckle and CBC assembly. This is a template type gauge, that is 10A contour gauge. It is checking the wear of the coupler head, knuckle face and guard arm. So it should pass freely. If the 10A counter gauge is touching the coupler head, knuckle face and guard arm, that shows that it is wearing more. So this coupler assembly is rejected. So it should touch and pass freely. It should come out freely. Now we are going to check up the working of the CBC by closing and opening, whether it is properly locked or not. So we are going to have a demo. Now it is opened. Again we are checking the closing. By pulling, knuckle is not coming out. That lock is completely locking the knuckle. That shows that knuckle is locked properly. Now we are checking with the clevis. Oh, now we are checking it. Now it is not coming out. The knuckle and clevis assembly is not coming out. So it shows that it is properly locked. Now we are now opening it. If it is now it is opened, now it is functioning properly. If these things are okay, the same knuckle and clevis all will be put up for the MPT coupler body and for further course of OH, that is MPT, cleaning, MPT and all we will do it. Now we are going to take out the CBC assembly. Before that, the transition assembly is to be removed from the coupler body. And using the crane, 50-ton EOT crane, now this is slowly it is being brought out. This slowly it is taken out. Now it is completely came out. In the continuity of CBC OH, now the next process is cleaning of all the CBC and its assemblies. Because CBC is very, very important one. So many areas are coming under the crack prone. So it is it's a opportunity for finding out the crack. In that, coupler shank we are cleaning, knuckle we are cleaning, screw coupling, yoke pin, clevis, all the accessories will be cleaned thoroughly, and it will be put up for the testing. That is dye penetrant method testing. It is for the surface crack and all. And another important is MPT, magnetic particle testing. That will be for the shank and knuckle. The MPT is used so that any cracks identified, diagnosed, immediately that component will be rejected. And as we know that this is very important for carrying a load. That is buffing and traction. This is through this only everything is carried. So if there is any slight even crack developed, it will lead to heavy damage. So we take the utmost care as far as the CBC is concerned. Now cleaning is completed. Next the process is measuring the parameters of the CBC assemblies. Out of that, now we have taken the knuckle. We are going to check the nose wear of the knuckle by using the nose wear gauge. So there are 4 areas. Out of 4 areas, 3 areas supposed to be touching with the knuckle. The one which is touching, it is good. The second, this is also touching, then it is also good. The third, now we are showing that is also touching. The center portion should not touch. This is very important. If the center portion is touching, it shows that it is wearing. The knuckle is wearing, so the knuckle is to be rejected. As far as this is concerned, now this is good. Now this can be paused. Another parameter is the stretching of the knuckle to be ensured, whether it is stretched or not. By using the stretch limit gauge, we are ensuring this is not stretched. So this also having a 4 areas. The one bottom one touching, The another area, this also touching it. Then the center portion, this is also touching. The last portion should not touch. If this is touching, means that the knuckle is stretched. Therefore, this to be rejected. Now we are going to check up the screw coupling, its parameters. By using the snap gauges, we are checking all the required dimensions. The first one is D shackle long, we are checking it using the snap gauge. So this is 39.5 dimension, that should not pass. The another side is 45, it should pass. So the wear is within the limit. The next we are going for the short side of the shackle. Here it is a 25 mm, it should not pass. Then the next one is the 29, that should pass. So these also within the limit. It shows no wearing at all. The another one is by using another snap gauge, we are checking the length of the long shackle. That is 278 mm. That should go pass. It should not touch the other side. If this is touching, that shows that the pin which is holding is getting worn out. That is to be changed. Other side short D shackle also we are checking the length by using the snap gauge. We are checking it. The same way here also, the 187 length, it should pass. It should not touch. If this is touching, the pin which is connecting the shackle and the rod is getting worn out. That is to be renewed or to be changed. Now we are checking the thread profile using the K thread profile. No light is passing, so this is the profile is good. Same way, small thread side also we are checking it using the K thread profile. Same way here also, the thread is okay. Now we are going to check up the diameter of the knuckle pin. Knuckle pin supposed to be 41.28 to 38 mm. So the measured value is 40.94. It is coming. So this is within the limit. Knuckle pin is passed. We are checking the diameter of the clevis pin. So the limit value given is 38 to 36 mm. The measured value is coming 37.96. So this also within the limit. This also passed. After completion of the measuring the required parameters on the components, now we are going for the MPT testing of knuckle and coupler body. Right now the MPT test is going on for the knuckle. All the areas are thoroughly checked with MPT. So far we find no cracks and all. We are continually checking. So we checked with the knuckle. No crack is diagnosed. This is the way we are checking the knuckle by using the MPT method, and this knuckle is found fit, no cracks noticed. Now we have come to coupler body. Here also we checked with MPT. The first one is knuckle pin area. This is a knuckle pin area. So mainly this is a crack prone area. So thoroughly checked, we found no cracks at all. Next is clevis pin area. Here also we checked with the MPT. So we found no cracks at all. The last one is yoke pin area. Yoke pin area. Here yoke pin is put. Here also no crack noticed. So all the three areas very important we checked with. And another stress relieving hole here. This also we are checking. Here also no crack noticed. So we are completing the MPT testing of knuckle and coupler body. The remaining part, that is screw coupling, pins, clevis and all, tested with DPT method. And with DPT also we have done it. Now no crack noticed. Now these components are ready for the assembly and it will be loaded in the Loco. Now we are going to have a DPT testing on yoke bottom portions. Penetrant applied. No. Yoke point hole we are checking it. Stress relieving hole also we are checking with the DPT method. Penetrant now cleaned. He is applying the cleaner. Now we are checking the yoke pin hole area, stress relieving area, and yoke bottom portion and dropped gear bottom surface. Drop gear bottom also we are checking it with the DPT method. By this procedure, so we did not find any cracks on the pinhole area and stress relieving area and the yoke bottom, dropped gear bottom. We have not found any cracks. Before loading the coupler assembly, now we have to see the drop gear proper working. Before that, we have to check the length of the drop gear packet. It's supposed to be 625. So in this case we have measured, it is 625. And condition of the drop gear is very important as far as the TOH is concerned. So we are checking there are 3 wedges, so that should be intact. There should not be any loosely held or there should not be any shacking. That we are checking. All the 3 wedges are intact now, and we are checking the piston movement by marking the chalk piece using the hydraulic press. After checking the intactness of the wedges, now we go for checking the piston. The piston should go inside and come out easily whenever we use the hydraulic press. So now we are trying to press inside the piston. Piston is moving inside. Same way we are releasing it. So the piston is coming back to the original place. It shows the drop gear is working properly. So because drop gear working is very important to observe any shocks at the time of during the course of work. Sudden jerks, in case it is coming, any impactness is coming, all should be observed in the drop gear. So this is how we are checking the drop gear movement. Now we are checking the striker casting liner, that is 8 mm thickness the conditional liner is to be checked thoroughly before loading the CBC. If there is any crack and all, it is to be changed. So precautionally we are checking it. Now this liner we have checked, it is good conditions. So, same way we are checking the shank liner 6 mm thickness. This is a shank liner. We are checking it before loading. Now its condition also good, so no cracks and all noticed. And we are checking the diameter of the yoke pin hole. Pin hole diameter also checked. Same way knuckle pin hole diameter, we are checking it. Clevis pin hole diameter also checked. All the diameters are within the limit. So now that shank is ready for loading, and whatever the data or measured values will be recorded in our respective document, use document. After completion of all testing, measurements, all important parameter checking, so now that coupler body is ready for loading into the Loco. So now it is being loaded. By using the 50-ton crane, it is lifted and pushed inside the striker casting. After inserting into the striker casting, the shank, yoke pin, the shank, it will be secured with the yoke pin, and that yoke pin support plate also will be tightened. This is how it is loaded into the Loco. After securing the shank with the yoke and yoke pin, now we are fitting the knuckle pin is inserted. Next we are fitting the clevis assembly with the screw coupling. Clevis pin is inserted. Now we are checking the movements whether it is locking or not. Now it is getting open. Once again we are checking it for proper locking. We are inserting the retaining pin through the 6 o'clock position. Lifting assembly is locked, and again we are checking for the proper locking. Now we are checking the proper locking of the knuckle. Now knuckle is locked. Now we are going to insert the safety pin. After inserting, it should be rotated to 6 o'clock position, and further trying to remove that pin, the pin should not come out. The same way, transition rod also we are trying to operate, that should not lift the locker assembly upward. So this shows the intactness of the CBC assembly at the time of coupling. Once it is coupled properly, this will not allow at any cost the couple getting opening. So now it is proved that it is properly locked. We are checking the lateral movement of the knuckle. The same way the beginning of the OH we have checked, the same way after loading, the same supposed to be there, the movements laterally left and right. So now it is moving, it shows it is normal. this is the procedure of CBC OH and the manuals G76 audios issued by Audiso and SMI 213 both are referred, and we are doing the OH as per the manuals and guidelines, and after completion of everything we record all the what are the measured values, all the parameters in the OH register, and necessary documents we are measuring. Thank you for watching this video.